Kconfig-Webconf is a performance-aware configuration frontend for Kconfig-based software product lines. Just like regular Kconfig frontends, it can be used to configure products such as the busybox multi-call binary. For instance, if the current busybox configuration is lacking the ls applet, we can use Kconfig-Webconf to enable it. In contrast to conventional frontends, however, Kconfig-Webconf can also show the predicted non-functional properties of the resulting product, in this case static memory usage and binary size. Although the busybox kconfig file already contains inline binary size annotations for most applets, Kconfig-Webconf allows for much more detailed models. For instance, we can also predict the influence of applet subfeatures, whereas the busybox project's kconfig annotations only cover entire applets. And, of course, we can save the resulting configuration with the ls applet enabled, rebuild busybox, and use it. As Kconfig-Webconf is a React application, it can be used both on a local machine and on the web. This makes giving stakeholders access to performance data as simple as sharing a link to a website, in this case for an embedded AI product line. Stakeholders can then select the non-functional properties that are of interest to them, see candidates for optimal products based on an experimental Pareto optimization feature, and of course see how changing individual system components, such as the hardware platform, would affect system behavior. All of this is predicted automatically from an NFP model. There is no need for manual annotation. We also support performance-aware dependency resolution. For example, certain AI frameworks are only supported on a subset of our product line's hardware. Even if the current configuration does not satisfy a feature's dependencies, we can enable guided dependency resolution, select the feature, and then resolve all missing dependencies. In this case, we'll select the Jet's Nano platform, as it is much cheaper and only slightly slower than the Xavier NX board. A key goal of Kconfig-Webconf is to add performance models to existing software product lines with minimal effort. This includes automated measurements and automated model generation. We now demonstrate this using the busybox model shown earlier. First, as a busybox-specific optimization, we disable compiler errors to minimize the number of build failures during data acquisition. Next, we need to add two targets to the project makefile. The NFP keys target describes the non-functional properties we want to benchmark, in this case binary size and static memory usage. The NFP values target uses a script to measure these non-functional properties after compiling a product line instance. In case of busybox, we also need to expand preprocessor statements and includes present in its various kconfig files so that we have a single kconfig file that can be loaded by Kconfig-Webconf. With that, we are already done and can start benchmarking. In this case, using the make randconfig command for random sampling. Once the benchmark is complete, we can use our toolchain to automatically generate a non-functional property model from the measurements. The resulting JSON file can then be loaded into Kconfig-Webconf and will automatically extend the displayed feature model with performance data as shown previously.